In this video, we're going to consider propositional strength. Now, in modern inductive logic, we're dealing with arguments where the conclusion only probably follows from the given premises. In contrast, deduction involves absolute proof, so to speak, absolute certainty. Induction involves the probability of an argument. Now, in inductive logic, the relative strengths of the premises and the conclusion help determine the probability of the argument. And that raises the question, what is a stronger proposition versus what is a weaker proposition, relatively speaking? Now, a stronger proposition says more. In other words, it contains more information in it, more content in it, whereas a weaker proposition says less. There is less content, less information in it. But because a stronger proposition says more, that means other things being equal, it must be less probable. And that's because a stronger proposition can only be true under more narrow circumstances because it's more specifying, it's more specific. A stronger proposition is more demanding, but because it is more demanding, it's less probably true. Whereas a weaker proposition says less. There's less content in it, implying that, other things being equal, it is more probable. And that is because a weaker proposition can be true under a wider range of possible circumstances. It's not very specifying. It's not very specific. It's not too demanding. But because it's not too demanding, it's more probably going to be the case. So given that, we can see that there is an inverse relation here. That is between strength versus probability, other things being equal. If we have something that's stronger, it says more, it's less probable. If we have something that's weaker, it says less, it's more probable. So we have more versus less. Inverse relationship, less versus more, inverse relation. And this has some perhaps surprising implications in terms of what is the strongest possible proposition or what is the weakest possible proposition. And we're going to get into that. But before we do that, let's consider some simple examples. Consider propositions 1 and 2. Proposition 1 tells us that there are books in this room, whereas proposition 2 says that there are philosophy books in this room. Note that proposition 2 is more specifying. It's more demanding, it's more specific. So that implies that the first proposition is relatively weaker, and the second proposition is relatively stronger. Consider propositions 3 and 4. Proposition 3 states that it is not true that there are 400 books in this room, whereas proposition 4 says there are 400 books in this room. Well, proposition 4 is strong. It's saying exactly 400 books. So this is strong, or stronger, whereas 3 says it's not true that there are 400 books in this room, or in other words, all other possibilities might be true, so that's definitely a very weak or weaker proposition. And note that proposition 3 actually is the weakest of all those propositions because it's saying it's not true that there are 400 books in this room, so all other possibilities, it's saying, might be true, so it's a very weak proposition. Now, we can't always rank propositions in a nice, easy manner in terms of what's weaker or what's stronger, but in this case, because we have similar content, we can do that. But I mentioned a pretty interesting aspect to this, and because we're dealing with weak and strong propositions, we can think of what would be the strongest possible proposition, where the probability, in fact, of it being true, so the probability of, let's say, proposition P is a big fat 0, because it turns out that the strongest possible proposition must be false. And we'll see why. We have a situation where we have a contradiction. Or, to be more specifying, we have a self-contradiction. Consider the example, Socrates is a man and non-man. This implies all propositions. That is to say, if we take this proposition here as true, then we can derive as true any proposition we would like. Consider the following argument. So premise 1, let's say we have M and not M. This is our premise. For 2, we can get M by the simplification of line 1. For 3, we can say M or some arbitrary proposition by the addition rule with line 2, and P stands for any proposition whatsoever. For 4, we can do another simplification to get a not M from line 1. And then, because we have M or P, not M, we can derive P because we have a disjunctive syllogism with lines 3 and 4. But P is any proposition. So notice we have really a maximally strong proposition. And a maximally strong proposition is self-contradictory. It's a self-contradiction with a probability of being true as 0. So it must be a false statement. So the strongest possible proposition we can have is necessarily false. In contrast, if we think about the weakest possible proposition, we're going to get a probability of that proposition as 100%. It's going to be something that is necessarily true. But it's only necessarily true in the sense that it's a tautology. It's trivially true. So here we're dealing with tautologies. Consider the example, if Socrates is a man, then Socrates is a man. So we really have if P, then P, right? It's necessarily true. And we can see that with a so-called truth table. So let's say we have P, and then we have P arrow P. Well, P can be true or it could be false. But if P is true, the conditional, if P then P, is true. But likewise, if P is false, we still get a true molecular proposition, namely if P then P. So we have this tautology. And so the weakest possible proposition is something that's necessarily true. It's going to have a probability of 1. It's so weak, it's trivially true, right? Whereas the strongest possible proposition is self-contradictory. It's necessarily false, and that fits within the rule we discovered that there is, in fact, an inverse relation between the strength of a proposition and its probability, which is pretty cool. But then we can consider the following. So if we have proposition P, and if P implies Q, but Q doesn't imply P, then P is stronger. Or in other words, if P is true, then it's impossible that Q is false. This means all circumstances in which P is true is a proper subset of all the circumstances that Q is true. So we might think that we have all the cases where P is true, and here we have the case where Q is true. Because P is true in fewer cases, it must be, or it is stronger. Another rule, which is even more obvious, if P is logically equivalent to Q, then P and Q have equal strengths as propositions. We really have a biconditional. We have P if and only if Q. They're going to have equal strengths. Whereas before, all we know is that P implies Q, but Q does not imply P. So now that we know what's a relatively strong proposition and what's a relatively weak proposition, we can then think about an argument as a whole, so to speak. So other things being equal, or in other words, ceteris paribus, the inductive probability of an argument varies directly with the strength of the premises and varies inversely with the strength of the conclusion. So it varies directly with the strength of the premises and inversely with the strength of the conclusion. And this makes sense. Consider this example. X number of widgets have been observed to work, ergo, the next widget will work. Well, think about X number. As X increases, the premises strength is higher, right? And so the inductive probability of the argument increases. So as X increases, the strength of the premise increases. And so does the inductive probability. But also note that the inductive probability varies inversely with the strength of the conclusion. So if we have a very strong conclusion, then the probability decreases. But insofar as we have strong premises, the probability is going to be higher because we have that direct variation. So we have varies directly with the strength of the premises and inversely with the strength of the conclusion. Now, I am the Amateur Logician from amateurlogician.com. This has been an overview of propositional strength, an important topic in inductive logic. I hope this video has been helpful to you and interesting. Perhaps you learned something. If you did, please consider giving this video a like. I would very much appreciate it. Consider subscribing to this YouTube channel if you haven't already. I have many resources on my website, amateurlogician.com. You can follow me at X, formerly known as Twitter. I also have an Instagram account, which I don't use that much, but I do have some content there that I don't have anywhere else. I don't have many followers. I have very, very few. But maybe I can get those numbers up. That'd be kind of interesting to see if that happens. I don't know. But thanks for your viewership in any case, and good luck to you. Be well.